Alright, so let's work on this project. For this project we are going to be importing the model instead of drawing it ourselves. So what we need to do is import it into Mastercam by going File, Open. Just so you know, I did take the files off of Blackboard and they are on my desktop just to ease that, to have less things open on my computer. So if I go to File and Open, I am going to go to my computer, Browse, and you can go to the desktop. I know I had the quick functions open already there, but I'm just going to show you this path, because that might not be the same for you. So make sure you're looking for step files. That's the file extension we're using out of SolidWorks. And down at the bottom you see mil7b. So again, make sure you look for the step files. This is the files it's looking for, okay? Before we select open, we are going to go to options, and I'm going to make sure solids is on. I'm going to turn edge curves off for this one. It'll give us more power later, a little more organization, but it is an option. What edge curves is it puts a 2D geometry, line, arc, at all intersections on the surface. There are tools to work with that later. So right now I'm going to leave that off. We'll hit green check, then hit open. And now you'll see our workpiece. Okay. So our workpiece is here. I am going to rename this level that it came in on as part. All right. And we're going to make sure we add a new level now. Okay. And then we can start getting into our stock definition. Okay. So I'll do a transition here, and then we'll get into defining our stock, which is what we ended up ordering to make this workpiece. Alright, so now we need to create our stock. The process plan for this workpiece is going to be, we're going to have it faced up like this in the vise as stock, because this part is 700 thousandths thick. We're ordering 3/4 inch stock, and that gives us some limitations on how we can machine this, and that's all on purpose. So we're going to face this side as minimal as possible, face to 0, then we'll put these 4 holes in. Okay, and we'll go right through the stock. Okay. The next operation is going to be bring it up over here. Okay, and we'll bolt it down, and we'll take care of the outside geometry. All right. Now we're able to hold it in a vise. Okay. Then we can place it in the vise. We'll grab it here. Okay. And then we don't need to bolt it down anymore, so we can take care of pretty much every other op on this workpiece. So that's going to be the process plan. Okay. So now what I want to do is create our stock. And our stock is going to be 4 inches wide, 3/4 thick, and we'll end up going 7 inches long. So to do that, we're going to go to Wireframe and make sure that your number 2 level is active. We will go into bounding box. I'm going to select the entire solid part model, hit enter, and I'm going to make sure that I put all the stock up in the Z positive direction. So we're going to align the stock, or this model we're creating, to the bottom. The size in the X is going to be 7 inches. The Y is going to be 4 inches, and the Z is 750. So you'll see our stock is sort of taking shape. Now this is not done yet. Okay, notice that if we go in the Z, all of the stock is up in this direction. We're parallel with the bottom. We need to go in here and make sure it's going to default to lines and arcs. You need to turn that off and go to solids and make sure it's going to create a solid model. So that's pretty much what we're looking at. Okay, then we will hit green check, and you'll see that we have our stock. One thing I recommend we do is I'm going to turn the visibility of the part off. I am going to go into the stock, right click on it, and I'm going to create some different color, maybe yellow. Get it to work. So we're good there. All right. And then you'll see the part there. If we go transparent, you'll see both. Okay. So we're good to go there. All right. Now we are ready to start merging in files. So before I do that, I will rename this as initial stock, or first stock, something like that. All right, we're good to go. We'll do a new level, and this will be fixture or vise op 1. All right, and we'll go. That's fine for now. And we're ready to merge in the vise. So I will transition here, allow you an option to pause and catch up, and then we'll merge our vise in. All right, so just before merging, okay, I'm going to turn the part and initial stock visibility off, and know that they're around the gnomon, so I'll put the vise over here and we'll position it that way. The reason I do that is because you can just keep merging things in and they overlap each other. It becomes difficult to navigate. So now what I want to do is go to File, as we merge. And I have this on my desktop. You can download it. You can look in your downloads wherever you put it. This is a Mastercam file. I'll just go to All Files, and there it is right there, the Kurt DX6 vise with hard jaws. I'll hit open. Okay, there it is, and notice it would be intersecting. Okay, so I'm going to move it, position it using dynamic. All right, I'm just going to pick some corner, maybe the corner of the vise. I'll bring it over in the X. I'll rotate it in the Y, -90. And then I'll also bring it up, rotating about the X. Okay, and that's going to be, looks like something along those lines. You want it sort of in the right orientation. So we'll hit green check. And there we are, there's our vise. Okay, so we're good to go there. We'll hit green check out. And everything looks good. So notice the jaws and the vise came in on different levels. That's okay. Okay. You know, it's up to you. It depends on if this is a Mastercam file, not how it's going to come in. Okay. So what I'm going to do is I'm just going to move the vise itself to the level 3 that I have. You could delete it and redo it, but I'm going to change this out. So I'll turn the jaw visibility off. I'll select the entire vise, right click, and I'll go to Analyze Entity Properties. Once I'm there, okay, I will go to Level. I'll select level 3. I'll hit green check. Then I'll hit this Propagate button, and it'll move everything to hit green check. Notice that's how I moved everything to Vise Op 1. I will then right click and clear all empty levels. The reason it didn't delete is because it's active. I thought it was active. So I'll right click and clear all empty levels, and that'll go away. Now the jaws are on here. There are obviously 2 vise jaws. That's fine. I will renumber this as level 4. All right, so we're good to go there. And now we have our vise, so we can put our initial stock and our part back in. Now it's very important you turn both of these on because you want to move them together. Now, what we need to figure out, all right, is what size parallel we want to use. Okay, so I recommend you go measure. All right, find a set of parallels, work with it. What I'll do right now, just to start getting you know, where you want this, is I'm just going to select everything here. I'm going to go to, it's already open here, dynamic. When you go to solid selection, a tools bar comes up, but you could also go to transform dynamic. We'll go to dynamic. I'll select the bottom left corner, or you could select the middle, which is not a bad way to go. So we'll select like in the middle over here. All right, and now we can move it around. So I'm going to select the middle, and I'll move it over, and I'll select the hard jaw, middle. Now I'm on top of the hard jaw. Okay, and we're centered. So that's not a bad way to go. So what we need to figure out, okay, is going to be where in here, all right, where we want to go. All right, so I'm going to take a look at my parallel set, and I'm going to select a set of parallels that I think will be appropriate. All right, and we'll go with 1 3/8 inches. All right. Now the question is, we don't really know what the height of this jaw is. You could assume if you know from Kurt what your jaws are, that's fine. But I'm just going to green check just to position that there for now. And we will then continue, you know, getting some sort of geometry here to see how the 1 3/8 parallels will fit, you know, where the height of this workpiece will end up, okay? So what I want to do is I'm going to turn Vise Op 1 level as active. I want to draw on this, you know, Op 1 vise, all right? And then I'm going to go to curve on one edge and select the bottom and hit green check. Now what I want to do is go into transform, translate, or dynamic, sorry. Select that individual line, hit end selection. Select the middle, and I'm going to go up in the Z 1.375. Okay, I'll look at that. That does look pretty good. That should work for what we're doing. We will then hit green check. So there's our line. That's what we need to translate to. Okay, we have plenty of stock on the outside. Now, if I were worried about these holes going through and hitting the parallels, I would actually bring the parallels in. But I'm not worried about that for this op, so we are going to skip that. All I need is this line. Okay, now what I want to do is go back to dynamic, okay, and I'm going to select the outside, okay, and there's a couple ways to think about this. You could try to select both, or you can just go into levels quick, and I'm just going to turn the vise and the jaws off. I'll select everything here, hit enter. I will then, while the vise is out of the way, select the middle, and then I'll turn the vise back on, okay, and I'll bring the Z only down to that line, and you'll see what happens. Okay, so now we should be all set. This is, you know, planned out for 1 3/8 parallels. Okay, so that's good. All right, we'll hit enter. All right, we're good to go. Now what we need to do is we need to bring this jaw in. Okay, so I'll select the jaw backing, the actual jaw itself, and the hard jaw, and hit enter. I'll select the, it could be in the middle, doesn't really matter. We'll select right in the middle. I'm going to select the Y only and bring it to the edge of the workpiece like that. Good there. Okay. Then we'll hit enter and go back to dynamic and just green check out. And selection, we're good. Now, I am going to delete these portions of the vise here, the guard, and even the threaded rod. That's not needed for what we're doing. Okay, so now this is positioned in the vise. I'll right click and clear colors, and we're in good shape. All right, it's a good time to save the file. All right. Before we pause for the next transition, I am going to position my work coordinate system. So I'm going to go to planes. I'm going to go to from geometry, or I'm sorry, hit escape here. I'm going to go to dynamic. I'm just going to select the top left corner, and I'm going to name this op in capitals, operation 1. And that's not critical, the capitals, that's just my preference, and I'll hit green check. So we're good there. Make sure the work coordinate system, C-plane and T-plane are there. And we are ready to start facing this and machining those holes on this workpiece. So I'll set a transition here, and I'll continue. Alright, so right before I machine this, I do want to make this a little more realistic. We'd be okay to machine these holes and face this and switch the orientation later, but just to keep this as, try to keep it as clear as possible. See how the bottom of the part, this is what we're going to be working with for this operation. In reality, we're creating this first. So what I want to do is actually spin the stock and the workpiece 180 degrees around the center of the workpiece. So I'll turn transparency off, I will turn the fixturing off, and then I'll make sure initial stock is active. Shouldn't make a big difference because we're going to use dynamic transform, or dynamic in the transform menu. Select everything, hit enter, and then you'll see an icon that comes up. It is white and blue. You're going to anchor to that carefully. That's the center of the piece. Select rotate about Y, type in 180. Make sure move is on, everything looks good, hit green check. Now make sure you turn the vise and the jaws back on, and make sure everything looks exactly as it did before, and it should have. We just pivoted it around. Okay, there's our line for the height of the parallels. But then you'll see the bottom of our part, and if we go to transparent view, we see more what we're looking at, a little more realistic. Okay, not super critical for right now, but I thought that would be useful. Now what we need to do is we need to create stock. Okay. It's a stock model per se. Now in toolpaths I already have a Haas 3-axis post and machine group loaded. Right before we do a stock model, I want to get into my tool settings and make sure that I select aluminum 6061 and the feed calculation from material. And then I also want to make sure my tools are sequential. Okay, so we're good there. We're going to ignore stock setup for this one. We're going to use a different method. So the first toolpath group that is here, I'm going to rename this as stock, or initial stock. Alright, and this will be just one toolpath group for our stock model. Alright, stock models are in toolpaths, and all it is a reference, and it allows us to define machinable area. It allows us to create geometry, as you'll see, that references material that's been removed. Okay, so it's a very useful tool. So the debate on whether to do initial stock based on a stock setup only, a stock model based on stock setup, or just a stock model based on the 3D model you created is up for debate. We're going to go the third method here. So we'll create a stock model. I'm going to get rid of the stock plane, make sure top is on. I'm going to call this initial stock. The color gray is fine. I'm going to turn the material to glass. If we go to view and go to material, it'll turn transparent. A lot of people do that. Thought it'd be interesting. We'll go to model. Then I'll go to the arrow here, and I'm going to click the left mouse button 3 times on the stock, and it'll select everything on the stock 3D model. Hit end selection. We're good there. Source operations, nothing's there. We should be good. Now, if you are using Mastercam 2022 and on, you'll see this generate toolpath option. All this does is allow you to avoid hitting the regeneration button each time after changing something. So we'll hit green check. All right, and we'll see our stock model in gray there. If we go to material, okay, you'll see it changes a little bit. All right, I'm not worried about that. So we have a stock model. Now notice to turn the stock model on or off is a toolpath, show toolpath. All right. So it's a little different way to do it. Very similar results. So now we're ready to machine. So I'll do a transition there, let you catch up with the stock model and things like that, and the rotation of the workpiece. All right, and then we'll continue with the facing operation and creating some holes. All right, let's do a facing toolpath. So I'll go to the facing in a minute, but the first thing I want to do is get this initial stock sort of on its own. So I'm going to go right up to the machine group, right click, and I'm going to select Groups, New Toolpath Group, so that the tree root is right in line here. So I'm going to go Operation 1. Now I can select Face. All right, I'm going to use the solid chaining method. Make sure loop is on, and select the outer boundary. Make sure it highlights before you click like you see on the screen. Click and hit green check. Now we go to Tool, and I already have a 2-inch face mill in there, but you can go to Select Library Tool and find that. The only thing is we need to take a look at this machine in here and see what we have for settings. Finalize properties. Notice that carbide number of flutes is 5. The feet per tooth is really low for this cutter. Now this is just default. This defaulted to high-speed steel. You could change it in here, or you can get into here, and we really need to change this. Now the surface footage is way slow. That's fine. We can work with that. But what needs to be increased is the feed rate. So let's take a look at a 3,000 chip load, and that again is very slow for aluminum. All right, but that's not bad. Just for reference, I mean, in reality, even a slow speed for aluminum, the chip load is going to be like that. So that's really, what you're looking for facing. But if you're concerned about actually when you go to run this in the shop, I recommend that you do detune it a little bit. Now, you got to make sure that you don't go too slow or too fast, but aluminum is very forgiving. So as long as you're, again, even 800 is sort of slow. It depends on what cutter you're using. So this is not a bad speed and feed. I'll just leave it there for now. Okay, because we're not taking a heavy depth of cut, so it's irrelevant. Anyway, I will change the plunge feed rate to 25 inches per minute. Okay, comment will be facing pass. All right, and that's not bad. That's a good operation here. I'm gonna ignore the holder for now. This setup doesn't warrant itself for that, to need to get into that. We'll use one way for the cutting method. We're gonna leave 0 on the floors. All right, and then all the overlaps and things we'll leave. I'm not worried about that for now. The step over, I'm gonna go to 50%, and I'm gonna turn reverse direction of last path off. All right, so we'll leave that. That's not bad. Depth of cuts we do not need. Linking parameters, the only thing I like to do on simple operations, I do like to leave everything as absolute. The depth is 0, top of stock is 0, it's facing to 0. Okay, so the point of that is it creates a 0. Now, when you set this up, if you use a probing system or whether you're touching off tools, you'll need to manually minus 20 thou, 10 thou in your tool heights or your work offset to actually cut material. That's not a bad way to go. If you're making 50 of these, it definitely helps. I recommend, if you can, always lather mill, face, and create a Z, 0, or whatever axis you're on, 0 for your workpiece. It definitely makes things smoother. Arc filtering is not necessary for this. Planes are good, op 1. Coolant will be on, and everything else should be okay. Let's hit green check, and there's our toolpath. Okay, and we'll just backplot the simple facing toolpath and watch it run. And again, we're not overlapping much. I do like to face one way. You could zigzag on this. You're really not taking much, but I find that the lines created on the workpiece are less if you do face one way. And again, we could take 100% step over. It's not a big deal. It's totally up to you. But this is what we're going to do for this one. Okay. And again, your speeds and feeds, you really should be calculating them based on tool manufacturers or any reference book. But the defaults on average on Mastercam are slower. Now I do have separate libraries that I use, that I've created, and different tools that I have preset up to speed this process up, so you're not really pulling it from your memory all the time. But I prefer if you actually put some thought into this and really pay attention to this area. I don't want to make it too automated, because then if you end up using a different software or you don't have those setups in industry, you're not lost. You want to really pay attention to your speeds and feeds. That is really a huge deal. It is definitely underrated. You really need to pay attention to this. Very important. All right, so we'll hit green check. And now the facing is done. So I will turn that toolpath off. All right, and I'll put a transition here so you can pause and catch up. And then we'll take care of these 4 holes. And then I'll decide whether I want to finish the rest of the holes in this op or do that in the second or third operation. All right, so let's take a look at this. Now, what I'm going to do here is these are all 1/4-20 tapped holes. So we'll take care of all the holes on this op. And that's out of convenience, but the one thing, I'm going to use at least 2 of these for locating. Alright, and I want to use this bore, and I want to make sure I circle mill it through, or Helix Bore, whatever we decide. Mainly because as we flip this, I want to be able to sweep this bore for location later on, and these will be clocking, and it's just better to get it done in this op. It'll make it by far easier later, because if we flip this and when we go to machine these holes and grab it in the vise, you'll see that it's going to be hard to locate if we do not have this bore to sweep. We could pick up the edges, but I still find the bore being more accurate. Alright, so what I want to do is I'm going to actually use the number 7 tap drill for 1/4-20 and drill all of these. It's probably not necessary for this big one, but I'm going to do it anyway. Spot drill and drill all these for number 7. That way, when I Helix bore most of these, you shouldn't have, it's easier for the cutter not to have to get rid of all of the material. So I'm going to go to drill, and let's spot drill all this. I'm going to select, what I'll do is I'll go to levels, and I'll actually turn the initial stock off. Get back into toolpath hole definition, and I'll end up selecting all of the holes. Okay, so I'll just go through and click, and then there are ways to select all holes the same size and things like that. But I think it's just better, especially when you're starting out, to just do it one at a time, where it's not that many holes. If it was a huge holes pattern set, I can show you that, but for now, that's what we're looking at. Okay, now the only problem is this one came in low. See that? So I do want to mess with that one. What I'll do is I'll just right click and I'll delete that one, and I'll end up just clicking the top. Alright, so see, that does look better. Okay, so we look good, everything's pretty good to go. We'll hit green check. Now what we need to do is get into the tool, and I'm going to go to select library tool. I'll go to the filter. I will unselect drill, go to spot drill, and I'll go equal to 3/8. Alright, hit green check. Create spot drill, green check. And this is good to go. This is high-speed steel, so we'll leave that there. That's not bad. This is fine for this. This would be spot drill. And then we go into, we don't need stock settings right now, and cut parameters, we'll leave it G81, that's fine. We could dwell, that'll shift it to a G82, G82 for spot drilling allows a dwell, but it's not really necessary for this. Linking parameters, I will turn everything on, the big thing here, I'll put everything absolute. Change the clearance to 2.0, make sure to change the retract to 100 thousandths. And then for the depth, okay, I will end up just selecting, I want this, if this is 1/4-20, I'll end up going, let's say, and you could tweak this at the machine. The issue is how you touch off and what spot drill you're using. Okay, if you go too far in, notice even the tool tip included angles 90 on the spot drill. I know that I want to change that to 3/8, so something to keep an eye out for. So this would be 118, not 3/8, 118,000 spot drill angle. If we go back into linking parameters, we'll end up going to, let's say, 0.260 for the finish diameter. I'm going to override the depth, no flat on the tip for now, and we'll hit green check. And that's only going to matter on the smaller holes, and we're just trying to deburr these at the same time. And again, once you run the first one, I know you're probably going to be making one, but you could always just do a quick Z- comp in the machine and be done with it. It's not a big deal. So tip compensation we'll leave off. Everything else is fine, except for coolant needs to be on, and then we'll hit green check. And we'll see our spot drill operation. Alright, we can backplot this. Alright, I don't see anything going through the workpiece, and again, we'll catch it later and verify if it's really bad. But backplot's a quick way to see simple toolpaths. Alright, so now we have that done. We can go through and drill these with a number 7 tap drill. So I will just right click, copy, right click, paste. And then I'm going to change some parameters. It'll, help me from changing too much again. Alright, so I'll go to tool, and I'm going to go to select library tool, filter, turn the spot drills off, turn the drill on, and I'm just going to go 0.201, which is number 7. We'll open that drill up. There it is. Speeds and feeds look okay. Alright. The only issue is the 4th thou could be a little aggressive, and that's the same with the 3/8. You have to be careful with the number of flutes. This is 2, it should be 1. Finish that and reinitialize speeds and feeds. Okay, that's better. we got that in there. I'm just gonna double check my settings. Tipping 118, one flute, everything looks okay. All right, that's fine for now. We could live with those speeds and feeds. Okay, that's fine. Now what we need to do is change this to tap drill. All right, we can go into cut parameters and we can go to peck drill, and we'll peck 100 thou is fine. Tip compensation needs to be on now. Linking parameters can now change to the full depth of the workpiece. We do want to go all the way through, so we'll go down and check the bottom of this boss, 700 thousandths. Then with tip compensation on, it'll automatically go past that. The one issue is that we are going to have some stock past. I will just make this 750 to ensure that we go through the workpiece cleanly. Planes, coolant on, everything's okay. I'll hit green check and we are good to go. Notice all the tools go well past. We're good there. I do want to go back into my spot drill and make sure the number of flutes there. This is number 4. We gotta watch that. Spot drills on a loon, I'm not really worried about the feed rate per se, unless you're really going too fast. If we go to 1 and go to finish, it's going to slow down quite a bit, which is fine. Okay, if we just reinitialize, perfect. Green check. All right. And one thing I want to point out, notice how it's, the feed per tooth is a little bit slower than advertised. That's going to be because in the feed and speed calculator, you'll see a reduction for drilling. Okay. So I'm not worried about that. You'll see it's a reduction here, but that's fine. Okay. So we'll live with that. We'll hit green check. And now all the holes are spot drilled and drilled. So now we're ready for other hole operations. And I'll do a transition here. What we'll do is we'll take care of the circle milling or helix boring for the larger holes. We'll tap the other holes, and then this operation will be done. All right, let's take care of the tapping next. Be quarter 20. So I'm just going to turn all the toolpaths off. And then I'm going to get into, I'm just going to reselect these holes instead of unselecting the other ones. It's probably 6 in one, half a dozen in the other. So I'll go to drill, and I'm just going to select each one of these separately. Knowing that they're already spot drilled, this will only be a tapping or rigid tapping operation. And we have to just make sure we don't know exactly what tap we're going to necessarily be using for this as far as lead-in. Just got to make sure that we're using a right-hand tap. And we'll get in here quarter 20. And there it is, tool 4. And I'm going to get the RPM to 100. I know that's slow, but it just makes the math a lot easier, and we're good there. This will be tapping. And we're good. Stock cut parameters, make sure the cut parameters is rigid tapping cycle. Linking parameters, we'll go to a depth down here, and that might have to be tweaked in the machine depending on what your lead in is. I'm going to end up going 0.8 for this one, that's fine. But just know that you may have to tweak that depending on if you're using a spiral fluted tap, a spiral pointed tap, a form tap, and if you are using a form tap, make sure that you have to update your tap drill size for that. Tip compensation, I'll just turn it off. Everything else looks okay. Make sure coolant's on, green check. And there's our tapping cycle. Let's quickly backplot to make sure we look all right. Alright, so that's all set. Good time to save. And now let's take a look. I'll turn that toolpath off. Let's address these other holes. Let's take a look at these 4 here. Alright, now we already drilled them 201. If I right click and go to Analyze Entity Properties and measure this, this is a 386 diameter. So a 1/4 inch drill or a 1/4 inch end mill is going to be ideal. You probably could go to 3/8, but I'd rather get more motion out of the cutter. So I think 1/4 inch is going to be the way to go. So we'll go to drill, and I am going to reselect these 4 holes, and then hit green check. And then I'm going to go in and select Helix Bore. Okay. The tool, if I go to select library tool, it's going to be a 1/4 inch flat end mill. Okay. Tool 5. Now, I will double check in here and take a look at the final properties. This is a carbide tool. I'll reinitialize the speeds and feeds for flute. Those are slow. I'll tweak that in here. That'll probably be okay. It is slow. I just want to make sure I really say that this is not optimal speeds and feeds for this. This is fine for what we're doing. Let's make one part. Helix Bore, small holes. So just realize that this is, we could run probably much faster, but this is fine for what we're doing, just a little bit conservative. All right, 1,000 chip load is pretty low for aluminum. Go to cut parameters. We're going to use wear compensation. All your lead-ins here, start at center, end at center, and a perpendicular entry. I want an overlap amount of 20 thou. The entry arc exit sweep, I'll put at 20 degrees. Start angle 90 should be okay. Stock to leave on walls and floors should be 0. Then we go to rough and finish. The rough pitch, I'll just go 10 thou, nice and easy. One roughing pass, no finish. The feed rate at final depth, that happens because it's just going to take one final circular interpolation around that. So, 30, even 20, 20% is fine. That's not a problem. Okay, you just gotta watch out for chatter, but we're not leaving anything, so it'll probably be okay. Just keep an eye on it at the machine. All of these holes need to go all the way through. So we'll take a look at all of our clearances again. Make sure everything's absolute, and again, that's not 100% necessary, but I prefer that. Change these parameters here, and the depth is going to be all the way through this workpiece. So 0.7. That's really not the end of the world. We want access to these holes for bolting through. So really, we should just go 0.8. That way we know we got it through. We'll have to double check that. So that'll be fine. All right. Everything else, arc filter, planes, coolant should be on. We're good there. Let's hit green check. And I'm going to go to top view and just take a look at one of these. All right. And I'm going to make sure I have decent linear moves on the way in. And we are ramping in here. There's a little circular move here. So we're good. That should work okay. All right. So I know that sometimes we'll get cutter comp interference here. That should work. If we do have cutter comp interference, we need to tweak those settings. So that's cool. So these are all set. We can watch this toolpath run. And like isometric reverse. And then we can go to backplot and watch them run. Now this cutter in particular does not have the length of cut in Mastercam. So that is not the end of the world, because as long as you know that for selecting the cutter, then you're okay, because in reality it would be. So what we need to do is, I'm just going to tweak this. So the overall length of the cutter is fine, the cutting diameter is fine, the cutting length is going to be 1.0. Okay? So we're good there. Shoulder length is fine, shoulder diameter is fine, shank, that's fine. So we should be good with the cutter. We'll hit finish, and if you regenerate the operation, you'll notice that the length of cut is much longer, and we should be good to go. Okay. Again, even a 3/4, 3/4 will even be pretty close. Okay. So that's the Helix Bore toolpath. What I'll do is, the only thing I don't like these retracts here before I transition. Get to parameters, and I must have missed that linking parameter. I meant to put 0.1, I put 1 in, so we'll put 0.1, and that'll save us some time. Okay. The other thing in here I want to double check is the feed rates when we start getting in there. Everything looks good. I'm just double checking a couple of things. So we're good there. I'll hit green check, regenerate, and now I'll transition into either the Helix Bore or circle mill for this, probably the circle mill, and then we'll be done with this operation and be ready to do the next op. Alright, so let's hide these Helix Bores here, and let's do a new drill toolpath. And we'll select this bore here. Alright, and we'll call it circle mill. The tool will still use a 1/4 inch end mill. Alright, speeds and feeds, like I said before, are going to be okay. This will be circle, mill, hole. And let's get into the cut parameters. We're going to use wear compensation. We'll make sure that there is a 0 on the stock to leave. Start angle is fine. The roughing, turn the step over, 50% is fine. Everything here looks okay. Plunge angle, 3 degrees. We'll go 1 degree. Z clearance, we'll go 50 thou, as short as possible. XY clearance, 10 thou will be okay. And then we can now get into the finishing. So we can turn finishing on, and I'm not worried about semi-finish, but in finishing, I'm gonna leave 5 thou to finish, 1 finish pass, and the speeds and feeds can be the same. I'll put keep tool down on and only at final depth. Transitions is very important. I want to make sure the lead in and lead out is on because we are using cutter compensation, start end to center, perpendicular entry. The sweep here, we'll just go 45 degrees, and the overlap will be 20 thousandths, and we'll double check that in a minute. Now, depth of cuts, we will use that. We'll go 100 thou each time. No worries about the finish pass. Keep tool down. We're good. We'll skip right over to linking parameters. Now, I do want to use this boss for locating or sweeping later on, potentially. I really want to use this for sweeping. So I do want to go deeper than necessary, just so I have this to work with. So I am going to go all the way through this workpiece, which should be 700 thousandths, or if I go in absolute. I do like absolute for simple workpieces. I know in other workpieces you cannot do this, depending what kind of geometry you have, but I think it does help in the beginning. So 0.7, we'll go 0.8 to make sure we go all the way through. Okay. Everything else is okay. Planes are good, coolant's on. Let's green check and look at this operation. Okay. Looks okay. Lead in, lead out moves look all right. So let's watch it run and see if we need to change anything. We may need to change our radial step over to see what it looks like. Can't be too aggressive. So it goes in and wraps around. Yeah, we could change that. I'm sure it would be okay at only 100 thousandths depth of cut. But what we can do is we could do a step over of 25%, just to be on the safe side. And again, that does affect the actual chip load. But for right now, we will live with it. Again, aluminum, it is very forgiving. All right, so there it cuts. All right, looks okay. Okay, and again, I'm looking for good size linear moves in with some radii in. Looks good. There's 2 of them, one for finishing, one for roughing. So we should be in good shape for that. It should go down past the bottom of the workpiece, so that way we can sweep that bore later on. All right, so I'm gonna save now. And then what we can do is we'll turn all the operations on. All right. And we will go into our simulator settings, and our stock model is initial stock, and the fixtures will be the vise and the jaws. Okay, very important, green check. Now we can get in here and we can go to verify, and hopefully our verification settings work okay. I will maximize this screen, and let's take a look at this thing cut. I'll slow it down, turn the precision performance for the graphics somewhere in the middle, and we'll watch it run. There it is facing. Again, you're not going to see anything facing because it faces to 0. You'll see a spot drill. Okay, and then we'll go in and it will use the number 7 drill to pre-drill all of these holes. I'll speed this up. All right, then we'll go in and this is the tapping cycle. And we have the circle, or the helix bores on these. And we have the circle mill on these. Okay, everything is through the stock. Everything looks okay. We had no apparent crashes. My collision detection did not pick anything up. So we are good to go for now. I'll transition here and we will start our next operation. All right, so I'm gonna get back into the levels here to turn my initial stock on. And that's just to get a good idea of what I'm looking at. So now what I want to do is I do want to create another vise setup. And I don't want to reuse this one. I know you can do that, but I like to keep everything kind of separate. So what I'm going to do is I'm going to go back into levels, and I am going to turn these 2 off. And then what I'll do is I'll go into transform, dynamic, make sure I select everything in here, hit end selection. Then I'll select, the corner of the vise here, and then I'll go to copy, okay? 1 instance, all right? Then I'll click and drag this over something, let's take a look at this setup here. Something that's 10 inches, so I'll go 10 inches, something like that. Now that is not a critical distance. Okay, as long as it's out of the way, we are good to go because we can turn this level off. So I'll hit green check. So now I'll right click and clear colors, and we have two vices that are identical. Okay, so now what I need to do is turn the part and initial stock back on. All right, the initial stock we won't need for in a minute. I will create a new level here and do op to stock. All right, and then I'll go into toolpaths and I'll go up to machine group, right click, groups, new toolpath group, and this will be stock or even op1 stock results. Okay. Now what I want to do is a stock model. So I'm going to go to toolpaths. I'm going to go to stock model, and everything is good. This will be op1 results. I want to go to source operations and select all of operation 1. Go back up here. Everything looks okay. We're not basing it on anything in the initial stock. You know, the initial stock shape is this model. So we can double check that again. 1, 2, 3, or 3 clicks. Quickly enter, and then we can hit green check. And you'll see in a minute we have a stock model. Okay. Now here you don't see much of a difference until you turn initial stock off. Now you see, and even if you turn the part off, you see what we created. Okay. Very important, because we're going to base our next, fixture on this. Okay. So what I need to do now is I'm going to end up creating a PMesh file and put that into the next level, bringing it over here and working with it. So to do that, op2 stock is on, and this is the op2 stock. The other levels are off. I am going to get in here just right now just to keep it organized and do a new toolpath group by, again, going into machine group, and this will be operation 2. Okay, so now we're separated. Now what I want to do is go into the toolpaths window and go to stock model, and underneath stock model we can go to convert to PMesh. Now once that happens, you need to select the stock model you want, and it should automatically happen after you hit enter. Okay, so I escape out. Now to double check that it actually happened, go over to the toggle display on the select operations and turn it on or off, and you will see a light blue, light green PMesh file. This is a piece of geometry that hopefully should be on our op2 stock. So now we have a piece of geometry. Okay, very important. So now it's time to get a little organized here. Let's take the fixturing for op2 and separate it in levels while we're at it. So we'll take these, we'll right click, and I'm going to go to Analyze Entity Properties. I'll put these on level 6, and these will be Vice, Jaws, for op2. Alright, and then we'll green check. So we're good there. And make sure you hit Propagate so we got them all. So now you can turn those on or off. Alright. We could even merge the Vice on the other ones to clean it up, but it's okay for right now to move the jaws. I'm not worried about that. We're leaving the jaws in the stock position. So op2 stock is here. Okay. Now we have to remember that we're going to end up flipping this workpiece, because if we turn the actual part on, which is going to be helpful, that has to go with us. Okay. So for right now, what I want to do is I want to select, everything here, and I'm just going to get it out in space. So I'm going to turn the Vice off. I'm going to go to Dynamic Translate, select everything, hit enter, and I'm going to say get this thing out of here. So I'm going to select the middle and just get it out of the way, make sure I hit move. Okay, or actually it's going to be copy. And it's very important now, because I want to leave the part there, all right, for the first stop. So I hit green check. We got 2 now, and that's fine. All right. They are in the the op2 stock is fine. I have to double check what I had for levels. The active level was here. We should be good to go. We're good here. So these, let me just double check the levels. I want these on op2, so I'll just right click, and really not this one. They are both going to be on. Got it. Let's check the part level. It should be on the level 1. Good. So the part, we could separate this, and we may later. Okay. The op2 stock, I am going to delete this one because we don't need it, because we have our stock model and we can create a PMesh whenever we want. Okay. So we have this geometry here, okay? And what we need to do is we're gonna flip it 180. So to do that, we'll go into dynamic, select everything. And I'm just gonna select the center like we did before. I'll flip this 180. Make sure I go, and actually I'm gonna hit escape quick. I'm gonna get in here and go to move, then go back to 180. And hit green check, and we're good there. I'll clear colors. And let's take a look at this. We'll see if we turn our Op2 stock off, the part actually looks how we're gonna want this, okay? So let's turn that back on. Now what we need to do is create a fixture plate that will reference this. So we need to do a little fixture design. Okay, so we're gonna have to translate the position of these holes, and then we can turn this off and start working with it. So I'll transition now, and we'll go from there. There's a debate on, and what I've been going back and forth with is, do I separate the part for each op? And I guess that's up to you. We could always do that later and change it. The levels you could always change, but it's nice to have one level all the part is on, because we're programming this to flow. Two vices would not necessarily be on the table. This could be the same vice. We're not even going to have different work offsets. We'll have different work offsets for Mastercam, but we're not going to post out 54, 55, 56, whatever. We're just doing this so that as you make it, this would be the same vice, different operation. That way you're not turning things on or off all the time, and you can actually see the process plan as we go. So there's a couple different ways to look at this, all right? One other thing before I transition is I haven't done any view sheets yet. It probably wouldn't be a bad idea to do so, and I really focus on the view sheets on the different work offsets. So right now I could just turn the op stock off, turn that off. This is our current one. I will right click in here and we'll just do save view sheet bookmark, so we're good. And I will rename it as operation 1. All right, so let's turn the op2 stock on and let's start making a fixture. So I am going to turn the initial stock, vice swap 1, and the jaws off for now. The part could even remain off for now. That's fine. I will get into toolpaths and I will turn the toolpath off for the stock model. So for right now, what I want to do is create a fixture plate. Okay, so the first thing I'm going to do is get a rectangle. So let's get into Wireframe, and I'm just going to do a rectangle, and let's work with this. There's a couple ways to do this. Instead of doing the rectangle first, maybe we want to do curve on one edge and get some geometry on the bottom of this. Doing that will really help. Then we can turn this off and start working with it the other direction into the fixture. So we'll go into levels, and I'll add a new level, and this will be fixture. And now what I can do, since this is the active level, I'll go into Wireframe, and I'm going to curve all the way around the outside, and then I'm going to curve all 4 of these circles and hit green check. And then what I'll do is I'll turn the op stock off, and you'll see what we have. Okay, so now what I want to do is I'm going to create a fixture that will hold this entire workpiece. So what we'll do is we'll work with let's say a 1-inch thick piece of stock that is 6 inches wide. We'll cut it to length that is 7 inches, just like the stock. So what I'll do is I'll turn the op2 stock off, the fixture levels on. One thing I want to make sure of when I do this is make sure the op2 stock, and make sure I'm going the right direction with this. So I'll leave it just there for now. Okay, let's get into Wireframe, and this is already 4 inches, so if I go into offset and go 1 inch each side, okay, see what's happening. All right, that should be 6 inches. And then what I'll do is I'll leave the length the same, and I'm just going to go to modify length, and I'll end up going to 1 inch, and I'll select here, 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 and here. Okay, so now, all right, we have a block that'll represent our fixture. All right, what we can do now is we could also get in here, divide, and get rid of some of this geometry. We do not need it. And other than that, we're good to go. I will clear colors, make sure the fixture level is active. All right, and what we can do is go into solids, go to extrude. I will select the outer boundary, hit green check, make sure we go away from the part, 1 inch, green check. So now we have our fixture. Okay. So now before we start editing the fixture, I will go into my levels and turn the vise on. Okay. And let's say we are still using the 1 3/8 parallels. But before we get into that, we do need to move this jaw out of the way. I'll get back into transform, dynamic, select the jaw and the back of the vise jaw here, and bring it back out of the way. What I'll do now is I will go to dynamic. I will select everything over here, making sure that my part level is also on. Select everything. I will then come on over here and select the middle bottom. Okay, make sure it looks right. Yep. That's good. And then I'll bring that over to that 1 3/8 line that we have to the midpoint of that, like that. So that's what we have. We could change our parallel sizes, but we have those parallels out already in theory, so we will live with it. All right, I will clear colors, and now we can close the the movable jaw. So I'll go to dynamic again, select these two. I'll just select any corner of it. Bring the Y only over to the corner of the jaw, and it should be closed, and we can hit green check. So now we have everything in place, okay? So what we can do now is we can focus on the fixture. So I'll turn the part off, turn op to stock off, turn the vise jaws off, or you can leave the vise on, it's up to you. And now we have our geometry, all right, that we can start working with. I will click on this, and right click, and I will change the color to maybe something that sticks out, something maybe green. And then I'll clear colors again to get rid of the coloring here. Now we're good to go. All right, so now I want to focus on the holes that we used earlier. And I want to bring up, I changed the PMesh and curved the PMesh on purpose because there's some issues that needs to come up with how you're working with these type of files, because they're not necessarily solid files. When we look at this, if we right click and go to Analyze Entity Properties, this is not a circle. It's a bunch of lines. And those lines are as fine as you derive them to be. So again, if we go to toolpaths and go to parameters and go to source operations, the path tolerance is 5 thou, tool shape 1 thou. You need to really, get those finer to get a better shape out of these. But again, they're still not going to be, there's even initial stock shape tolerance. It's not going to be a circle. You could extrude them, it's still not going to be quite right. That's not the end of the world. Okay, the lines obviously worked out, and I have worked with them before. It depends on what your tolerance is. Just know that the tighter the tolerance, the longer it's going to take to regenerate the operation, just like any other type of toolpath. So instead of working with these, knowing that you're either working at a distance or potentially on a computer that doesn't have a lot of processor speed, what we can do is go to levels and let's turn the part on. Okay, what I'll do is I'll actually delete these 4 circles we derived from the PMesh, which are identical to these 4. And what I'll do is I'll go to curve on one edge, making sure that the fixture is active, and I'll curve the bottom of the part. Okay, so once that's done, I could then turn the part off, and you'll see these 4 circles. If I right-click Analyze Entity Properties, now they're a circle. So that's something I wanted to bring up. Can you work with them? Yes, in 2022, there is a mesh function. You can work with a lot of this stuff. And that seems to be the general trend. But I just wanted to make that a little easier. I think it might pan out better for you guys, or for this class to do that. I think it'll be just simpler. So now what we can do is get into solids, and I'll extrude, and I'll select the circles we just created. And make sure we select Add Boss, very important. We'll select 1/8 of an inch up and hit green check. Now what we can do is we can put the tap drill size hole, which is a letter F or 257, through these holes. And the reason for that is we are going to use a 5/16 18, all right, tap to hold these down. The bosses will locate. We probably get away with 2 bosses, but we'll use 4. If you get into levels, which we are on already, we'll go into the actual part and you'll see what I'm talking about. These holes here are 386, so using 5/16 18 there's plenty of room, and it'll have plenty of room on the fixture between the threaded holes and the boss. So we'll turn the part off, and then what I'll do is I'll simply, instead of going to the hole function, I'll just do it in another method. I'll select the center here, and this will be 0.257 diameter. All right, hit apply, and I'll just do that 4 times. No, you could array it. You can do a lot of things here, but I'm not worried about it for now. There's only 4 holes. So 0.257. And we'll do the last one. Okay. And now we can go into solids, extrude. Make sure you select these features. Hit green check, make sure you cut body, change direction, and it's going to be through all. Okay? So we're good there. Hit green check. So now we're ready to machine. Okay? Should be good to go. We'll take a look at this now. I'm just going to put the part on quick to take a look. Looks good. If we even put our Op2 stock on, that's what we're going to be looking at. Looks good. Alright. So now we're ready to start machining this. Before I transition into that, I will end up going into planes. I'm going to make a new plane. Alright. And it's going to be dynamic. I'm just going to pick the upper left corner. Make sure that looks right. And this will be fixture. And hit green check. And then I'll also, because this is a new work offset, I will do a new view sheet. This will be fixture. And once that's done, right click and save view sheet bookmark. And again, the point of that is when you click each one, it is a quick way to get moved around between operations levels and planes. All right, so now we're ready to assign toolpaths. All right, so for right now, I will transition. I will end up just bringing the cursor down, and right now we're ready to do toolpaths. Okay, so let's start the machining operations for the fixture here. I do need to update the stock for the fixture. This is the actual fixture we want to make, so I need to update what the stock is going to be like. I'm not going to face any of these sides. It's going to be a one-time use fixture, so I'm just going to put this in the vise and machine this portion at the top. So what we can do now is I'm just going to do a new level, and this level is going to be fixture stock. Okay. And that's active. Then I'll end up going and turning off everything else. Leave the fixture on. And we will go to bounding box, select the entire fixture, hit end selection. Okay? And we'll see that it'll actually automatically create a solid of what we had before we actually, or not before, but taking into account these bosses. So I'll just hit green check. Okay? And then we have our fixture stock that we could use later on for our simulation purposes. Okay, so I'll turn the vise back on for Op2. Back to toolpaths. I am going to rename operation to fixture, just to stay a little more organized. That's up to you. And now we're ready to actually start machining this. Okay, so to machine this down, all right, there's a couple options. We want to take down pretty much all of this in one shot, and then we can drill and tap afterwards, or you can drill and tap first. It really doesn't make a difference. We should probably just take care of the drilling and tapping now and mill second, so we can get into the toolpath groups, and we'll go to drill. And I'm going to select the surfaces. You don't have to. You can select the circles on the outside, but the surfaces work well. We'll hit green check. And this is going to be a drill toolpath. We'll go to tool. I'm going to get in here and go to the filter. I'm going to double check, see what I have in here. Actually, I'll probably just see. We got tool number 2. So we'll work with tool number 2. That's fine. I will double check. This should not have changed, but I am double checking the number of fluids and things like that. So we're good to go here. This will be spot drill fixture. And then we can take a look at the other options, cut parameters, change that back to drill counter bore, whole segment. Some of that we're going to need. Linking parameters, we are going to need. The one thing we need to change, and I'm just going to green check out of here, is that I will end up moving my gnomon up a little bit. That'll be, you don't have to do that, but it's a little less that you have to take into account. You'll see what I mean. If I turn my stock on, this is totally fine to be there, but we're going to have to touch off and modify to go down. So I'm just going to go into planes, and I'm going to right click on the fixture, edit. I'm just going to bring it up only in the Z to that line, and we'll hit green check. All right, so we're good to go there. Now when we get back into our operations, we can take care of our depths and things all in absolute, and it'll make a little more sense. So the depth, this is going to be a 5/16 hole. So the finished diameter for this, it's at 257 tap drill size. We're just going to go 0.320 for the finished diameter. Hit green check, and we'll use that for now. Everything else should be okay. Make sure the coolant's on. That should be on from previous operations, and then we'll hit green check. So now I got our spot drill, and we moved our gnomon up. Okay. So now what I want to do is I'm just going to right-click, copy, right-click, paste, and now we're going to do the drill operation. So now we're going to select a different tool. Go into the drills, equal to 0.257. Should be a letter F. Check. Okay. Everything's good. I will double check. I always make sure this is there. Right. We're good there. Okay. What else we got here? Again, remember the reduction for drilling. Just that's the default on this material in Mastercam. Again, I'm not running optimal in any way. I'm just running really conservative, something that will, be easy to run for the first time running through this program. Cut parameters, this is going to be pec drill, 100 thou pec depth is fine. The linking parameters, the depth is going to be all the way through. And we'll end up turning tip compensation on to take care of the rest of the way. Everything else should be okay. We'll hit green check. Alright, so now we have our spot drill and drill. Okay, so now we can take care of the tapping operation. So I'm just going to copy and paste, and not even copy, just paste again. And then I'm going to get into here and we'll take care of our 5/16/18 tap. So we'll get into tool operations, select library tool, filter, and again, when I search for taps, I just go to ignore for the diameter and I search for it in the list. There we go. We'll go for 100 RPM. Alright, and cut parameters, make sure you go to rigid tapping cycle. Linking parameters. The depth for this one, I'm going to select through. You just got to make sure you're not going to shank out. I'm going to leave tip comp off. You just got to make sure the tap you select, you're not going to shank out or go too deep. So just keep an eye on that. Everything else here is good, so we should green check. And there's our tapping operation. Okay. So now the drilling operations are complete for this fixture. I'm going to do a transition so you can pause and catch up and rewind whatever you got to do to get to this point. And then we'll take care of this top surface using dynamic style toolpath to get rid of most of the material, and then we'll come back in and use contour to finish the arcs with cutter compensation. Alright, so let's rough off the top of this workpiece, and we're going to use a dynamic style path. And whether or not you used that before is irrelevant. We'll work with it now. The name of the game with these dynamic style tool paths, OptiRough, things like that, is going to be a full axial load, so a full depth of cut, and a lesser radial depth of cut, or a less step over. So basically what that does is you get full flute length, or as much flute length as possible, cutting with less of a step over, but then Mastercam automatically will calculate the toolpath to keep the same chip load on the cutter and the same, angle of cut at all times. So it's the same chip load at all times. Okay, they're very efficient. Now they're going to run faster. The chip load is essentially, you could call it the same, but since you're taking a lesser radial depth of cut or less step over, you need to increase the actual IPM of the machine to keep the same feed rate or the same chip load, and that's called radial chip thinning factor. And I'll talk about that. I'll show you how to program that in Mastercam and what that's all about. The other thing that we're going to have to start getting into is going to be the arc filtering. to keep the programs as short as possible and as smooth as possible for what we're doing. And I will show you that in here. Also link a video to that, to the differences in that program, in that setting. So let's take a look at this. So we'll go up, and I am going to turn the stock off for this one. We don't need it. I just want to be able to see easier. So I'll turn the fixture stock off. Back into toolpaths, we'll go to dynamic mill. All right. So we're going to go from outside. Sorry, we're going machining strategy from outside. The avoidance regions are going to be what we're going to avoid, which are going to be these bosses. So we'll select these bosses, okay? So we are in the 2D chaining method. That's up to you. If you want to chain down here, that's fine. You can go to the 3D solid chaining and chain here. That's fine too. It's up to you. So we'll just use the 3D chaining method. And we'll hit green check. And then we'll come back here. We will take care of the machining region, okay, which is going to be this outer boundary. So we'll go to machining region, solid change, and loop the top. So now we've defined what we want to leave with avoidance and where the material is. One of the nice features here is go to preview chains. This is what's going to be cut in red, and the blue is kind of where the toolpath can kind of go, where it's free to move. And you can increase that. We're going to roll with this for now. But for right now, you know, that's fine. But this is an awesome tool. It really uses preview chains. Okay, so we'll hit green check. Now we go to tool, and let's see what we already have in here. We do not have any end mills in here. So let's go to select library tool, and instead of a 3/8 end mill, let's use a 1/2 inch end mill. This has to be a sharp end mill. It can't be a bull mill to get these radii. So we'll go to 1/2 inch. Select a 1/2 inch end mill, and there we go. We just got to double check the 1/2 inch end mill and make sure that we have 4 flutes. We will use carbide and hit finish. Now, so we have tool 8, 1/2 inch end mill, fine. Pretty self-explanatory. Here's the deal here, all the speeds and feeds, these are slow, okay? We can tweak these at the machine. I'll be honest with you, for a pass like this, I mean, especially with such a less depth of cut, you're gonna be at, you know, like 12,000 spindle speed and 100 to 200 inches per minute, depending on how your machine, you know, how fast your machine can go. But I'm going to leave this here for now. What I want to focus on is this checkbox, radial chip thinning factor. Turn that on. You'll see it. Both of these go away. That's because now they're synced up in cut parameters with step over. So take a look at tool. Notice how we're at 28 inches per minute. If we go to a 5% step over, and go into tool, see how it increased the feed rate. To get the 2 thou chip load, you need to increase the inches per minute to get the feed rate because we're taking less of a radial step over. Okay, so that's what that does. It does the math for you. So for us, okay, I want to run at let's say a 600 surface feed for this, and let's put the chip load to 3 thousandths. That's still conservative. This will be rough fixture. All right, and then we get into the cut parameters. Now, the distance for step over, this is aluminum. Typically it's 8 to 10% for most materials, but I have found up to 25%, and aluminum does work. So we will end up using, let's say, 20%. Okay. Stock to leave on walls and floors. On walls, we'll leave 5 thou. On floors, we'll leave nothing. Right. The back feed rate, this is the feed rate that between passes when it's hopping around, it'll micro lift up and feed. We want to go pretty fast, so 500 inches per minute. And we'll leave that. There's a lot of parameters here, but I'm going to leave a lot of them for now. You don't need a lot of these when learning. We'll address these as we go as needed. Okay, there's no need to memorize everything. Again, the help menu is always there. Corner pre-treatment we don't need. Depth of cuts we're not using. Entry motion, we're going to go plunge only because we're plunging outside the workpiece. The Z clearance will go 50 thousandths to save some time. That's when it starts feeding. Linking parameters, the depth will be the top here. And I am going to go ahead and put that in absolute. You don't need to, but I prefer to use that method. Clearance, we'll go 2 inches and retract 0.1. The arc filtering, okay? I'm going to do a transition here, and I'm going to come back. I want you to watch the other video listed on specifically arc filtering and what it's all about, and then we'll continue from there on this workpiece. So I'll do a transition and watch that video. It'll be the arc filtering video on Blackboard, or it's a YouTube link, so it'll be on there. It's one of the videos I did on a previous assignment, and then we'll come back and continue. Alright, so for now you should have watched the arc filtering video and what it's all about. So for this example, we're going to turn line arc filtering on just in the G17, just in the XY plane for this toolpath. I'm going to increase the tolerance to 2.5 thousandths, and I'll split the cut tolerance and line arc tolerance 50-50. Alright, that'll work perfect for this. We could use some smoothing settings, but this is perfect for this one. There's no reason to do more than that. So that's fine for now. Planes, of course, we'll check. We're good. Fixture, coolant. Make sure you turn the coolant on for this one. Now, in steels and stainlesses, depending on what cutter you're using, and pretty much you don't need it. You could use air. But aluminum, to avoid melting the material into the cutter, just turn the coolant on for this. Then we'll hit green check. And you'll see this is going to take a little bit to compute this one. And you'll see the toolpath. Okay, you'll see where it leads in and cuts around. So we can watch this one. A good time to save. And we'll watch it run, and you'll see it keeps the same chip load the whole time. It actually flows pretty well. Alright, and works its way through. Okay, so we are all set. Okay. Looks pretty good. The only thing I like to do now is if I get into view and advanced display and make sure vectors, argument points, and endpoints are on. Right, looks good. Okay, so that's our roughing pass. Okay, we're good to go. All right, I don't see a lot of odd moves. Everything looks pretty good to me. We could increase the arc filter tolerance. In reality, the only thing is I hate to increase it more than half the tolerance. That just makes sure that it's not going to go. You don't want, if you watch the video, it tells you and gives you examples of each detail. I don't like to push this necessarily to like the 5 thou, we're leaving 5 thou on the walls. I'd cut that in half, and I know I'm going to be safe. I know the tool's not going to gouge in randomly, things like that. Probably doesn't make a difference for this one. A little gouge here and there is not going to make or break this fixture, but you're safe here. So hit green check. And now we're ready to finish these. Alright, so to finish these, we'll go to contour because we want cutter comp to be used. We'll select the solid arcs on the top of these bosses, but make sure we're going counterclockwise so we can climb cut. Okay, so we'll change direction on this one, select the next one, change direction, select the next one, change direction, next one, change direction. So they're all going clockwise so we can cut around. Okay, climb cutting. Click green check. Now we'll go to tool. We'll select the 1/2 inch end mill. Speeds and feeds are okay. This would be boss or just finishing. Alright, rapid retract is fine. Cut parameters. We want to use wear compensation. We're leaving nothing on the walls and floors. That's good. No depth of cuts. Lead in, lead out. The only settings here is going to be like a 20 thou overlap. Everything else defaulted should be okay. The linking parameters. I turn everything on in absolute. You don't have to, but it does help to keep things simple. 0.1 for the retract, feed plane 0.1, and the depth is going to be -1/8 of an inch. There we go. Arc filtering is not necessary for this. Planes are fine. Make sure you turn the coolant on and hit green check. So you'll see our lead in, lead outs. It looks like we have plenty of room here. There's no need to really modify this or go crazy with that. Everything looks pretty good. We are bouncing around, but we're not hitting anything. So there's our finish pass. This is a good time to save. And now what we can do is we can go isometric reverse. And what I'm going to do is I'm going to select everything. I'm going to go into my simulator settings. The stock, I'm just going to go to a solid. And you go into, to select a solid, I'm going to end up just turning the fixture stock. I'll turn the actual fixture off and select the stock. Then everything else looks okay. I'm going to turn the vise for fixturing. I'm going to do the Op2 vise and jaws for operation 2 only, hit green check. I will get back to my levels and turn the fixture back on and the vise and jaws for Op2 on. Then I can go into my verify and hopefully my settings are correct. and we'll take a look what we got here. So I'll maximize this, okay, slow it down so we can see what's happening. Spot drill, right. Drill, make sure it's through, we are. Tap, alright, and we'll watch it mill around. Alright, and again, we could probably go much faster, but for the first time actually cutting dynamic milling toolpath, this is not a bad way to go. So again, you see how it keeps the same load in the cutter the whole time. Okay, so there we are. And we'll hit play and we'll finish them. These are all set, so the fixture's done. Okay, so I'll X out of here. Good time to save again if you already haven't. And now what I'll end up doing is I'm just going to do a new toolpath group now. And this will be Op 2. Alright, so I'll save again and I'll pause the video, do a transition. I'll let you catch up. The fixture is done. Now we can start programming the second op. Alright, so I have the part workpiece on, the part level on, and we're just looking at the workpiece. And basically what this op is going to be doing, again, the stock's going to look something like that. And we're going to end up creating just the outside of this workpiece. Okay. So the only thing we really have to go on for our 00 is going to be, we'll set this bore as 00 because we machined it out in the last operation through on purpose. And this bore is a little bit easier to work with when probing or sweeping the indicator than these four are. So it's up to you whether you want to use this and this. We're going to adjust to this one. So what I'll do, and again, it's up to you whether you want to have this on a separate level or not. We might change that later. It's totally up to you. This is the part stock. If you want to keep the part on for all three ops or not, if it does bother you, you can just right click and change the level. It's totally up to you. So for right now, I'm going to go into planes and I'm going to do a new plane, dynamic. And I'm going to end up selecting just the middle. And again, you got to watch the, you have to watch the PMesh file because it's not as useful. It's like an STL. So you can end up turning that off for now. Select the bore. Now we know we're aligned. Then you can end up turning the Op2 stock back on, selecting just the Z-axis and syncing up to the top of the workpiece, like that. Okay, so that's good. Hit enter. And I'll rename this, this will be Op2. Okay, green check. And we're good there. So now what I'll do, it's a good time to do a view sheet bookmark. So we'll go something that makes sense, something like that. Should be fine. We'll add a new view sheet. This will be operation 2. And I'll right click and save view sheet bookmark. And again, there's Op 1, there's the fixture, there's Op 2. Okay, kind of a nice tool. So now for this op, what we really need to take care of is going to be the outside of the workpiece. Okay, so that's pretty much just going to be a dynamic milling toolpath, and we'll take care of the outside. Right. One thing I want to do is I want to define where the stock is. Okay, so to do that, we can do that. There's a couple ways. We'll see how it chains just the PMesh. It should be okay. The solids aren't bad. But if we have to, we could always go into Wireframe and do our either a rectangle if you really wanted to, or a curve on one edge and work our way around that way and do a 2D chaining method. So for Op 2, let's work with this. Let's get into toolpaths and let's do a dynamic style toolpath. Okay, the machining region in 3D. Okay, notice how it doesn't really select. It selects down here, doesn't select up here. Okay, not a problem. Let's see how 2D works. It doesn't pick up anything. Okay, not a problem. So this is what we do for fix that. I'll X out. I'm not going to save it. Okay, what we can do, all right, is I'm just going to end up going to Wireframe, and you could do a rectangle. You could pick the corner and go corner, or and I'll do it that method while I'm here, or you could do the curve on one edge method. Now, one thing I want to be careful of that is on the Op2 stock. I want to see that one on the fixture level, so that was my fault for being rammy on this one. So I'm going to select all of these, right click, analyze entity properties. I'm going to put them on the Op2 stock level. Okay, hit green check and propagate, and we're good to go there. And hopefully I did that right. Op2 stock, we're good, except for I selected the bottom of the device. So you need to be very careful. Okay, right click, and you can move these around as you wish. It's totally up to you. All right, and we'll go from there. So Op2 device, we're good to go, and Op2 stock, we're good to go. Okay, so again, the levels, totally up to you. Good time to save. Now, let's get back into toolpaths. Make sure the red cursor is below operation 2. And we have to remember we're going to have some bolts hanging up here, but that shouldn't be a problem. Just remember that. You can model them, import them, put them in. That's fine. And make sure you're not going to have a collision. It's totally up to you. So what we can do now, toolpaths, dynamic, the machining region, wireframe kind of chain, there. And then what I want to do is I'm going to go to, it's going to be from outside, the avoidance region. If I go to levels, I'm going to turn the Op2 stock off. I am going to go to 3D chain, and I'm going to select the bottom of the workpiece like that. All the way around. Green check. So we're good there. I'm going to go to preview chains. Looks good. See how it's getting rid of our stock, leaving our part. And the boundary on the outside is fine. The blue area for it to move is excellent. So hit green check. And now we go to tool. Half-inch end mill is fine. The speeds and feeds are okay. The cut parameters will be okay for this one. 5 thou leaving on the walls is fine. Entry motion is going to be plunge only. Linking parameters, the depth is going to be down at the bottom. And we could leave it there. You could go a little bit deeper. It's up to you for this one. Now, this is all depending on where we touch our tools off. Okay. It really doesn't matter for this one because we're not creating thickness. We are only creating the outside boundary. So whether we touch off the top or the bottom, as long as we create this wall and there's no excessive material to have to remove later, we're good to go. There are times where if I'm working with this, like if I was trying to create the pockets in this op, which we can't because the bolts are in the way, I would set the bottom to 0, set my tools off to 0 or probe to 0 and work that way and work up. But for this one, it's irrelevant, so we'll just select the top of the workpiece. It's not a big deal. So we're good there. And again, this might plunge into the workpiece a little bit. This distance we'll have to take into account, all right? Right now it thinks it's 750, but we probably removed a little bit of material, so this number has to correspond with how much you removed in the first operation, okay? So let's say I'm just gonna go, let's say you could go 700 because we'll have room to grab onto it in theory, but then it's not going to be the best. So you do want to create this wall. So let's just go, let's say we're taking 20 thou off, we'll go 730. And then at the machine you can comp that in, it's not a big deal, okay? You just got to make sure that you have a good wall surface to grab in the vise for the third operation. Everything else looks okay. The arc filtering should be on, planes up 2, coolant should be on, and we'll hit green check. So there's our operation. Okay, it looks good. All right. Now let's take care of the finishing while we're at it. We'll go to toolpaths, and I will just turn that toolpath off, and we'll go to contour. I'm going to select this bottom loop, green check. Now that is going to conventional cut, so I do want to go back into chain geometry. It is a solid chain. I will right click on the loop and reverse. And now it's gonna climb cut, green check. Tools me the same cutter, that's fine for what we're doing. The tolerances aren't super tight on this area. Wear comp's fine, depth of cuts is off, lead in, lead out with an overlap is fine. Linking parameters, 730 for the depth, keep that in mind. Everything else should be okay, green check. There we go. All right. So now we can save. And let's update our simulator settings. So for right now, what I want to do is I'm going to turn on the Op2 stock so I can go into my simulator settings and solid mesh. I will select that stock. Vice jaws, I'm also going to select the fixture. for obviously the fixturing. And we might have some collisions with the fixture, and again, that's okay. We just got to make sure that when it does stop for collision, that this, it's only hitting the fixture. Now, this thinks it's 3/4 of an inch, when in reality we did mill, we faced a 0 before, and we faced a little bit off. So it should not hit, but just something to keep, when you get to the machine, some things change. So you just got to, sync up what you're doing in Mastercam to what you want at the machine. So hit green check. And now operation 2 is on. We can go to verify, and let's watch this run. Hopefully we have all of our stuff on. It looks good. So we'll hit play. Okay, and that bottom piece is fine, because again, we got to remember the material is thinner than what we're expecting. So don't worry about that for now. Alright, so now we have it all roughed out. We'll come back in and finish it. Looks good. Okay, so op 2 is done. Good time to save. And now what we can do is we can start getting ready for the final operation, which will be taking care of the rest of this workpiece. So I'll put in a transition now, and we'll continue and finish this up. Alright, so let's get ready to do the final operation. So we'll turn off the ops here. We'll do a new toolpath group. I will start minimizing these now. Alright, and this will be operation 3. Okay, so now we can start moving our vise over. So that's one of the first things I'll do. I will actually do a new level, and this will be vise op 3. And then what I'll do is I'll go to transform dynamic, and I'll go to my levels, turn everything off. Okay, except for vise op 2. Select everything and hit enter, and then make sure in dynamic we'll end up just moving it. Make sure copy's on, and I'm going to move over in the X, let's say 10 inches. Something like that. That made sense before. Then we'll hit green check. Okay, so now if we right click and clear colors, and we turn off op 2, now see they're on the same op, so I will have to change that, which is fine. I will end up, let's double check my 3, nothing, perfect. So I'll highlight, if I go to top view, highlight this whole vise, right click, and I'm just going to change it now. And I'm sure there's a setting in dynamic that I forgot about, but anyway, we'll put it on op 3 vise, green check, propagate, green check. Now that vise is separate from this vise. Okay, so if I go reverse isometric, we have 2 vices, and actually if I even put on vise op 1, you'll see we have 3. And again, you will not have 3 at the machine. Okay, this is just doing a process plan. You could have 3 if you're making a bunch of these, but we're just doing this so everything is separate and it's easier to follow in Mastercam by turning on or off levels or view sheets and things like that. So I'll turn that off, that off. Now we need to take a look at op 2 stock, and we need to do a stock model from op 2. Alright, so let's get organized in our toolpaths here. I am going to rename this operation 3. This will be op 2 results, or stock results, to keep some continuity. Then I'll do another toolpath group. This will be operation 3. Okay, so I'll move the red cursor below op 2 stock results, and now we can create them. So now what we need to do is go to stock model, and I'm going to call this again op 2 results. I'm going to select the initial stock shape as a model, so I'll click the arrow here and select the PMesh file that was the original stock for op 2. Then I'll go into source operations and select op 2. Alright, not worried about the tolerances, it's just a rough stock model, everything looks good. Okay, so let's hit green check, and hopefully it's in the right position here. So it looks good. Let's get into levels, and I'm going to turn the op 2 stock off, and we will see, even if we put part on, we will see the stock model created. So that's what we created. And again, this little tab here on the bottom, okay? May or may not be there depending on what you do in Op 1, okay? But just shows you how, you know, it does give you exactly what's going on, what you're looking for. Okay? So, the only issue here now is that this is going to be in our way. Okay? Alright, because it's going to interfere with how this is going to look visually. Right? How do we fix this? Right? What we need to do is go back and change the depth on the other operation. Okay? But be aware that that depth has to correspond with the thickness of the workpiece. Okay. The reason we did not take a fixed amount is because we want to take the minimal amount for the material to clean up, and we won't know that until we're working with the actual piece of stock you cut. All right. So for right now, let's tweak this so that it's accurate. The other thing we could do is actually just make a new model. So there's a couple options here. So what we can do is I am going to update the stock model for this one. So let's get back into toolpaths, okay, and let's look at operation 2. Okay, what I'm going to do is I'm going to get into, and it's up to you whether you want to modify the high-speed toolpath or the contour. It really probably doesn't make a difference. It's up to you. If we go to parameters here, and we can go into the linking parameters, and this will be 750. Same for this. Okay. Now, notice how Op2 stock results is a dirty operation. If we regenerate it and turn it on, notice how that material is gone. So as you update your stock or update your operations, the stock models go with it, which is very handy. Now again, just be very careful. We are going to hit the fixture by doing this. In theory, at the machine. Okay. Now we could change the 0, 0 here. Okay, just to go to 0. That's another option. Okay, it's up to you. Right. Op 2, if you set the 0 to the fixture plate, it's just going to go to 0, which is the top of the fixture plate, and cut what's ever there, regardless of height. Not a bad way to go. Right. That is totally up to you. Alright, so I figure I better show you what I mean about moving the gnomon. It's not a bad idea. It's actually easier to set up touch-off tools. But again, this is just something that you have to worry about as a programmer, syncing up to the machine, you know, what's going on. Again, because we want to take off the minimal amount of stock on Op 1 to make sure we're not going to cut the part too thin. We only have 50 thousandths of material to work with. So what we need to do is I'm going to end up just turning on some of the levels. So I'm going to turn on device for Op 2 and the fixture for Op 2, and now we're pretty much focused back on Op 2. Here we are here. What I want to do now is move my 0, 0 down to the fixture plate. So I will go to planes, I will right click on Op 2, select the Z direction, and click the top of the fixture, then hit green check. So now a lot of this changed. If we regenerate this operation, okay, here and turn it on, we're going to have some cutting going on, especially down here. That's a problem. Okay, up on top is probably okay, but let's tweak this. And the reason for that is because it's where the chain geometry is coming from. We chain the bottom, and whether or not we're an absolute or not is how things flow. The absolute versus incremental geometry. All right, so let's tweak this. Although this one looks okay, we did update this. Let's look at the linking parameters. We are an incremental. That's what saved us. That's why this looks good. If we go absolute and select the top plane, it's going to be 0. That's what we want. The top of stock is going to be up here. Okay, if we go absolute, it doesn't really make a difference for us. It'll be 0.75. That's fine. Now, we have to watch our clearances and feed planes. They should be incremental because they're going to come from top of stock. If we go to the help menu and go into absolute incremental values, you will see incremental values are relative to other parameters or chain geometry. Depth and top of stock are relative to the location of the chain geometry. Clearance, retract, and feed plate are relative to the top of stock when incremental, not when absolute. So if I get out of here, turning those incremental will save us from having to, do some math when you're in absolute, because the 0, 0 for the Z is now the bottom of the workpiece. Okay? Now we can hit green check. will regenerate the op. It should have already regenerated, but we are good to go there. All right, take a look at our clearance planes. We should be good. Okay. I'll look at both of those later once I see, we'll backplot and check that. Now, the contour we have to mess with. The contour should have almost identical linking parameters. So if we change this to incremental, 0. Incremental for top of stock will be the top. Everything else should be incremental. Then we'll hit green check. Mine automatically regenerates, but if you're in a 2021 or older, you just hit regenerate the operation, and you'll see what happens. We are good to go now. It is going right to the bottom of the workpiece. Okay. Now, 0, 0 for the X and Y is still the center bore of the part, but the Z0 is the top of the fixture. Okay, just a different way to go about it. A few different ways to think about it. Whatever works for you is what to work. This is what we're going to go with for now, because this is what I have. I will regenerate the stock model for now. Let's watch this operation 2 run. I will double check my simulator settings. Should be good to go. Let's watch this and verify. And we'll hit play. And notice we are just going to Z0, so we're not actually going to hit the workpiece. Okay, everything looks good. And we'll come back. I don't see any crashes at all. We look pretty good. No collision stops. I will turn the Op2 stock off and just double check my retracts. Everything looks okay. Nothing's going through the part. So we just updated our work coordinate system to give us a more universal setup. Again, not mandatory. I recommend you do this for programming purposes, but if you're actually going to run this part, so when it comes to actually making it and handing in a made part, like if you're in lab running this part, it's irrelevant. If you're learning how to program and you're in the Mastercam course, then I would prefer you do it this way, just so I can see that you're following along with the video, right? So now this is done. Okay, I will transition here and we'll get back into getting Op3 finished. All right, let's get into Op3. So let's get these toolpaths off for operation 2. Let's minimize Op2 and Op1 stock results. Let's look at the stock results. We are good to go there. So now it's time to start getting the levels right. So we'll turn the fixture off, and once you turn the vise off, and let's turn the vise for Op3 on. So that's good. Now what we can do is I want to create a PMesh of the stock for this stock model here. Okay, so this is the stock model I want. If I go down to here and let's do convert to PMesh, the only thing I want to have on is make sure I have a new level active. That will be Op2 or Op3 stock. All right, make sure that's active. When we go into toolpaths, we can now start getting our PMesh file created. So I'm just have stock model on here, double check my levels, make sure that Op3 stock level 10 is active, and then I'll get into stock model and I'll do convert to PMesh. You'll see our file up here. Okay, now it's time to move everything over. Okay, now we might get lucky and our parallel height that's been the same throughout this will work. If not, we will adjust for another set of parallels. So for right now, what I want to do is I want to change the view a little bit, and I'm going to grab everything here, okay, and I'm going to use dynamic transform to position it, but I'm going to make sure that copy is on. Now, I will go back like I did before and delete the PMesh, but we want to have the part be a little, the plan we've been doing so far is having the part on the same level, so we can see the process plan. We don't have to do that, but that's what we're doing so far. So right now, I want to get into dynamic. I can select, what I'll do is I'll select the bottom corner here, okay, and then I can position this. So what I'll do is I'll move this part, something that makes sense, something like right there. And we'll look at this, and actually this will work. Okay, we look at the line we got to create. We don't have any interference because the holes are done, so that will work. Okay, so this does work for our stock. We'll line up with the edge of the jaw. I don't see any issues here. Maybe they'll come up later, but for right now, we're good to go. We'll hit green check, and we can now clear colors. And now we can start by, I'm going to delete this PMesh because we have that in stock model whenever we want it. All right. And now we're ready to focus on this op over here. So let's move our jaw in. So we'll go to Dynamic, select the jaw and the actual portion of the vise, and we'll drag that in. So I'll just click here, click the Y, and we'll click this line right there. And then I'll make sure that move is on because we're not copying that one. Okay, now that did not transition correctly. Let's get into a view that actually is somewhat helpful. Click the Y again. Alright, make sure it's only the Y, and select that line there. So that makes sense. Okay, so we look pretty good there. We'll hit green, check. Clear colors. And now this part is ready to machine, using the same parallels we've been using so far. Okay, so we'll get in operation 3, we'll bring the cursor down, we will save. I will double check my levels, I'll make sure the part is there. Vice op 3 is there, op 3 stock is there. Let's create a view sheet and update our gnomon before we transition here. So now the gnomon, okay, we have some options. It could be the bottom of the workpiece, be the top of the parallels. We could face to 0, which is probably what we're going to end up doing. It's up to you how to set the 0, 0. I'll go to planes, and I'm going to actually treat this, like we're running more than one part, where well, it's up to you. There's a couple different ways to think about this. If you're making more than one, then you would want to face it by hand until you get the thickness, and then you could set your 0 there. That's not a bad way to go. But since we're not really worried about that right now, we are really going to be worried about the thickness, because as long as we get the thickness, it doesn't matter. We're not, like the first op, we're not cleaning up by hand until we clean up the minimal amount. We can set the Z0 at the bottom, which is going to be the top of the parallels. Okay? Now, probing that and touching off gets tricky, but it's not the end of the world. The biggest thing here is going to be that we either probe the top of the parallel, or we get a gauge block buildup that we can probe from, or we probe the bottom of the vise and compensate our number up. It's up to you, right? But we will do a new dynamic plane, and we will select the bottom arc, the bottom of this workpiece. That is our 0, 0. This will be operation 3. Okay? Click green, check. Now, what this means is we have to watch our incremental and absolute values, and I want to make sure we hit that home because that's very important. So that's good for right now. That's 0. All right. And now we could do a new view sheet, which is going to look something like that, which would be fine. Do a new view sheet. This will be operation 3. And I can right click and save view sheet bookmark, and then we could go through and you can check all of our operations. All right. Now is a good time to save, good time to transition, and we'll take care of the final machining operations. All right, so let's face this thing down to height here. So we'll get back into toolpaths, make sure our toolpaths is in the right location, our red cursor. Otherwise, we got to copy and paste. And then we'll get into a facing operation. Okay, I'm just going to do the outside boundary here. Now again, this stock model is not going to reference well, so we'll just do the bottom. Okay. Then we'll change our linking parameter. So the tool will probably be tool 1, which is a 2-inch face mill. The speeds and feeds are okay. This will be facing. And then we get into cut parameters. One way is fine. Stock to leave 0 distance. 50% is fine. Verse, everything should be same from last time. Depth of cut, we're going to go incremental. And we're going to go to there. And then we're going to go incremental top of stock, which is going to be there, which is sort of irrelevant. It's going to be 750. That's fine. This is all from the chain geometry. Then everything else here will be incremental from the top of stock. So that's good. Retract will put 0.1, feed plane 0.1, or it could be 50. Either way, that's fine. Arc filter, planes, op 3, coolant should be on, and we're good. So that should be good. We'll double check where that exists. Looks good. Okay, we are taking some additional space here. But we'll leave it for now. If that becomes an issue, we'll address it. Again, it's irrelevant over here because this is not going to be there. Okay, so just make sure you take that into account. So that's good. So now we'll get into op 3, and now we'll worry about the actual boss here to mill this down. Then we'll take care of the other pockets. Let's work on that now. So let's get into levels. Now I am going to turn this stock off so you see what we're working with. Then what we can do is we can do a dynamic style toolpath just to face all this material out. Okay, so let's do that. Let's go to toolpaths, dynamic. All right, the machining region, I'm going to select as this area. The avoidance region will be this area. Okay. Let's take a look from outside at our preview chains. Looks good. Okay, shouldn't have any issue. I'm not worried about it coming up and over here because I'm going to leave some material there, so we should have a nice easy transition here that we'll take care of with a contour toolpath. So that's good. For the tool, we'll pick our 1/2" end mill, which is fine. Speeds and feeds are okay. They are slow, but we'll live with it. 5 thou is fine. Everything else is okay. Entry motion, plunge only, linking parameters. Now, the depth is going to be here. Okay, absolute 1/2 inch. Top of stock is going to be the same. It's actually 0.7, but that's fine. It's not going to make a difference. Everything else is incremental. Should be good. Arc filtering is the same. Planes are right. Coolant's on. Green check. And there's our toolpath. You'll see it dodging around a little bit. That's fine. That's the way it's flowing. Okay. So what we can do now is let's watch this run. So in toolpaths, save it. Simulator settings. The solid mesh we're going to use, if we turn the levels back on, is going to be the op3 stock. And then we do have to update our simulator settings. We'll go back into levels, turn that off. Go back into here, and the fixturing is going to be the op3 vice. So now we can watch operation 3 and verify. And we'll slow it down, and we will play this. All right, and then we will run our dynamic toolpath. And see what goes on. Alright, good. So, before we go to finish anything, let's do all of our roughing first. Okay? So I'll turn that toolpath off. And now let's take care of this inner pocket here. So let's do a dynamic style toolpath just to get rid of this material. So go to dynamic, and the machining region, I'm going to select as this area. Okay? And I'm going to select an air region. It's this area. That'll tell the machine that's an air area, a nice place to plunge. Okay, because that's already been machined through. We'll preview chains. Okay, now we have an issue. That's not good. So what do we do to fix that? Go to stay inside, preview again. Now that looks ideal for what we're looking for. Green check. We need to get in our cut parameters. The tool and everything should be fine, but the linking parameters need to update. So the depth is going to be here. Top of stock is right. Everything else looks okay. Green check. There's our machining operation. Let's watch it run. Verify. And hit play. Excellent. So I know we circle milled the first one, that's fine. This one we just roughed out this way. We'll use a contour pass later on to take care of that. Let's hit save. And now we can go through and let's do a dynamic style toolpath to rough all of these out. Okay, so let's right click and analyze entity properties and click this arc, and that arc is a 1/4 inch radius. So our 1/2 inch end mill is going to be a little big for that. We can go to a 3/8 cutter, and the 3/8 cutter will be able to rough a lot better. We could rough it with a 1/2 inch and then use a rest mill pass, but I'm not worried about that for now. I would just change cutters, and we'll rough them out with a 3/8 cutter. So I will go into dynamic, and let's do machining regions. These 4 pockets. You could do a transform toolpath, but I'm not worried about it for this one. We're good there. And let's green check. Let's check preview chains. That's perfect. Green check. Let's go into tool, and let's select a 3/8 cutter. Now I don't have one in there. I do have a 1/4 inch flat end mill. Okay, that I think I was using for finishing. I will double check that in the previous ops. Let's do select library tool, filter, 0.375. 3/8 flat end mill, excellent, green check. Let's look at this tool and make sure we have 4 flutes and that it is listed as carbide. Finish. I will update. The speeds and feeds are okay. They're a little bit slow. I'd say maybe we probably still get away with a 3 thou. That should work. Plunge feed rate 25 inches per minute, just to work down there. That's okay. We're good there. This will be pocket roughing. That's okay. So again, it's a little on the slow side, but we'll live with it. Cut parameters. Now, the 20% step over, I'm going to minimize that in the situation we're in. So let's go to a 15% step over. Okay, we'll leave 5 thou on the walls. We will, the depth of these pockets, depending on the tolerance, we could finish it, but for right now, we'll leave the stock on the walls. That's fine. Leave nothing on the floors. The entry motion, we are going to do it helix only. The Z clearance 50 thou is good. The plunge angle 2 degrees. Let's go to 1 degree just to take it easy. And the helix radius, that's fine. We could update our entry speeds and feeds. That may become necessary because we are going right down to the bottom. We're not going that fast anyway, but if we go to like 35 inches per minute and the spindle speed of 2500, that's fine. And we'll put a dwell of like 0.5 seconds, just to allow the spindle to boot up. Okay. Linking parameters, again, the depth will be there. Top of stock is actually going to be here, and everything else is incremental and good there. Arc filters are fine. We're leaving the same amount of material. Planes, coolant, good. Green check. There's our operations. Okay, and we can turn all of these on now. Hit save. Let's verify this op. Let's run this. So we'll do op 1. Face it. Rough it out. Rough that out. Take care of the pockets. Okay. That's where we're at right now. So it's a good time again to save again. I'm going to transition here to give you a minute to catch up, and then we'll take care of, it looks like we'll be ready to finish this workpiece out with a contour toolpath. Alright, so let's finish these operations. One thing I want to point out, I do want to use this 1/4 inch end mill used in circle mill and helix boring. Those are finishing these to somewhat precise numbers. Some of these are, within 2 thou on size. So if we select a 1/4 inch cutter for most of our finishing, although it is roughing these, we should be in good shape. It is aluminum, so I'm not really worried about it. Again, we're only making one piece. If we were making a bunch of them, I would have separate finish passes for these, but they're not doing a lot of work. So I will use that 1/4 inch end mill to finish. So let's get into here. I'll turn these operations off. Let's finish the work we did in here. So we'll go to contour, and I'll select this one, okay, and I'm going to change direction. So it's climb cutting. I am going to select only this arc, okay, so I'll go to here to edges, and just that one edge, okay, and I'll change direction in order to climb cut. All right, I'll hit apply, or end chain. Then I'll go to loop again, and I'll select these bottom surfaces, making sure I am climb cutting. Okay, gotta watch that last one, and green check. So now we'll go to tool, and we're gonna select the 1/4 inch flat end mill. Speeds and feeds are okay for now. This is finishing. 6,000 might be a little high for chatter. I kind of want to say it's going to be, so let's say like 4,000. Keep an eye on that. Okay. We're not taking a lot of material, so wear is fine. Depth of cut's none. Overlap, all that's fine. We might have to reduce that. We'll see how it goes. We'll go to linking parameters. And the linking parameter, we need to be very careful with our absolute versus incremental. Okay. So the top of stock is going to be incremental. These come from the chain geometry, okay, versus the depth, and again, that can come from the chain geometry. So we want to end up going to 0, okay? That's why it's important that we chain at the bottom of the pockets, the bottom of this pocket, and where the cutter is actually going to go, okay? The top of stock is going to be incremental from the chain geometry. Now we can change that You could put that one to absolute if you really wanted to. You know, if you go absolute to there, it's 0.7. That way all of these will be above. That's fine. Okay, that's the reason why we shift these around. Everything else should be okay. We'll hit green check. Let's see what happens. So, looks like all of our lead in and lead outs work, except for these two. We need to change them. But these other ones do work. That one's fine. That one's fine. Okay. So now everything looks good. All the Z depths look okay. The only problem is going to be these pockets. So let's go back into our chains. And we need to work with a couple of these loops. So we'll go ahead and go to this loop, and we will right click and we can reverse it. Okay, that makes sense. The arrows on this side, we're climb cutting. Go back to this loop. Okay, that one looks okay. Let's hit green check. Let's regenerate the operation. Okay, and now we have an issue with our start points. Notice how these two, the start points are on a flat, these two are not. Let's go back and edit that again. Again, go to geometry. We can go to this loop, right click, and we get in here and it's going to be start point. Okay, so we can go backwards, forwards. It's just going to go to each of these intersections. Okay, we could pick one, maybe that one. We hit enter. Okay, this one here, we can right click and we can get in here and go to start point. We can go backwards or forwards. Let's try maybe that one. Hit enter. Let's hit green check and let's regenerate the operation and see if our lead in lead outs are there. Okay, they are. Okay, we look like we're in pretty good shape. Let's reduce the amount of lead in and lead out just to make it a little cleaner. So we will get into our lead in lead out settings and let's change both of these to cut them in half. Okay, and we'll cursor over. All right, looks good. All right, the length is half the cutter. Now, we probably want to increase this. Again, that won't give us a lot of room for changing the cutter compensation a little bit, but 65% will. The radius is fine. Everything looks good here. Let's green check and regenerate, and it automatically did for me, but that looks much better. So it should be in good shape. Again, we moved a decent amount here. Got to make sure you lead in at least at least the radius of the cutter, what you're trying to compensate. But you got to remember, even 50% would work for us because we're using wear compensation, which means you're only comping 10 thou maybe max. We're not trying to actually, if we did computer method or control method, we would have to be very, very careful with that because that's when you would type in the diameter of the cutter into the controller and you're compensating the radius. So for wear, we're not worried about it. We can get away with it. Everything here looks pretty good. Right, so there's our finish passes. We can watch this in backlot. Alright, so let's run through these operations. Good time to save. Good time to go to op 3. And we can verify this. Let it boot up. That. Hit play and watch it face. Play again to do the first roughing, second roughing, the pockets for the roughing, the 3/8 cutter. And we'll come back in and finish everything up. Everything looks good. There's no collisions. Okay, so we're good there. All right. So this part, geometry-wise, is complete. Again, I'll save again just to be careful. What we can do now is let's do a final deburring pass just to clean this up. So I'll transition here so you can catch up, and we'll do a model. This in here, we'll do a model chamfer to finish this up. All right, let's do that model chamfer operation and take care of some of the deburring for us. We'll take care of this arc, this arc, this arc, and the pockets. I'm not going to worry about the outside here necessarily. I'm a little worried about this transition here, which you could work around, but I don't want to have people trying that, mess it up, and damage their workpiece when they could just deburr it easily with a file. Same with the holes. I'm not going to worry about the smaller holes. We could take care of it. It's not a problem, but let's just focus on these other pockets. So we'll get into here, and we'll go to model chamfer. Okay, and the chain geometry. All right, I'm going to select this chain, this chain, this chain, Okay, I'm gonna say green check. Let's see what happens here. So we'll get in here, we'll go to tool, and now I have a tool set up for this. It is an 1/8 inch chamfer mill. So I will get into the database, and if you need this, let me know. I'll send it to you. There's my 1/8 inch mill drill, so I'll hit green check. And we're good there. The speeds and feeds for this, 5,000 RPM at a, 3,000 chip load is fine, even a nice finish. All right, now again, I have this set up. You gotta make sure this is available in the shop. These tools get broken off, and so if this is not available, you can just omit this operation. But I thought this would be kind of helpful. Cut parameters. We're gonna use wear compensation. The bottom offset's gonna be like 15 thousandths. All right. Chamfer width is gonna be 15 thousandths. All right. Depth of cuts we're not using. Lead in, lead out is fine. We're gonna overlap 20 thousandths. Cut parameters, everything should be okay here. Clearance 2.0, and everything should be okay. Coolant on, all right. And we have to double check, make sure all of them appear. We might have to break it up because they're at different Z heights, but let's hit green check. And we have most of them. Okay, it looks good, all right. Let's take a look at the geometry here. So I am going to tweak this. I got to tweak some of these. Notice the ones where they're out are good and the other ones are not. So let's get into the loops. This one is good. Or that one needs to be changed, so let's reverse it. Okay, or change side. Alright, you got to be careful because it will change all of them. So you might have to go through and reverse separate ones. So that one's okay now. That one's okay now. This one's not. So we can reverse this one. This one is okay. This one is okay. That one is not. Reverse. This one, reverse. Okay, so let's hit green check and regenerate, and if we're lucky, all of them will now appear. So there they are. Okay, looks good. And what we'll do is we can backplot this to see what goes on here with the. Just go ahead and just touches the surfaces very lightly. Okay, and again, you could do more than this. We could get into here and tweak that. We could do the holes, but for right now, that's enough. Again, I can't guarantee that a mill drill or these chamfer drill mills will be available, but I just wanted to expose you to this for now. So what we can do is save, select all of operation 3, and we can verify to make sure we have no issues. All right, we'll hit play. So there's the roughing after these pockets will be completed. Then it gets into the finishing, and we'll slow it down and wait for the deburring. Okay, so there it is. There's most of the difficult deburring done. All right, this part is complete. I don't see any other operations that we are missing. Okay. One thing you could always do is a stock model at the end to make sure it looks just like the stock. So we could do that now. We could do a new toolpath group. And this will be final stock model. All right. And then we can get into stock model. The original stock, we have a couple options here. We can pick a stock model. This is going to be the op2 results. Okay, or we can pick a model. So it's up to you. We'll pick a model for this one. We'll go into levels. We'll pick op3 stock and select the model. The source operations will be operation 3. All right, and we'll tweak it. Well, we'll leave that for now. I was going to refine that, but it can be rough on the computers. I'm not going to worry about stock compare. We're just seeing how this looks. We'll hit, this will be final. Then we'll hit green check, and we'll see what it looks like. Toolpaths, and let's see where we're at. Make sure we're in the screen here. I will turn the op3 stock off, and there is our stock compare. I don't see any odd material there. I do see the chamfers. You can see the chamfers there that are not on the model, but that's okay. Everything looks okay. All right. Again, you could apply the deburring tool passes to the other sides, but I didn't think it was worth it for this example. They can push a little bit of a burr. You got to make sure you have the tools available, and that's my main concern here. So if you are in lab doing this, make sure the tool is available before you run that toolpath. If you want to use that modeled chamfer more on the other passes, feel free. It's a fairly simple operation. So anyway, it looks good. I don't see any material where it shouldn't be. Again, I'm just looking at the transition between gray and blue, and that's a telltale that I think we're in good shape. So that's it for this one. I will save, and again, you can go through your view sheets, okay, and see what's going on. All right, and that's it. All right, so if you want to run these, you're going to pick op 1, op 1's on, post them all separately as you go through the operations. One thing that's helpful, if you right click here, you can always go to tool list. That'll generate a tool list for whatever is selected currently on the screen. If you want the entire tool list for all operations, select everything, right click tool list, and it'll give you the complete tool list for everything on this operation, 10 tools total. If you want them separately, just pick op 1, right click tool list, and it shows you just for op 1 what is necessary. Okay, so that's it for this one. Hopefully we'll see how these get produced, and if you have any questions, make sure you email me or arrange time to meet either using TeamViewer, Zoom, or in person. Thanks for watching.